Here we're going to take a look at a process that's called completing the square. And we'll start with the technique of squaring a binomial. That'll lead into the later work. Now the recipe, in a sense, is to take the first term of the binomial and square it. That'll give you x squared. You then take these two terms, multiply them together. That gives you 3x, and double it. That'll give you 6x. Then you take the second term of the binomial and square it. That gives you a plus 9. And you might try this one, but we'll do it together if you'd like. We're going to square the first term. That gives you x squared. We're going to multiply these two terms together. That's 5x. Now you double it, and you get 10x. And you square this second term, and this gives you a plus 25. Again, square the first term. Now, multiplying these two together, we get a 2/3 x. But now doubling it, it's just multiplying it by 2, and that will give you 4/3 x. And now you need to square this, and that will give you 4/9. Now, as we look at these trinomials that were produced by squaring a binomial, we have ended up with what is called a perfect square trinomial. And they have certain characteristics. The first term in the trinomial is always a perfect square, and so is the last term. Now, the first and last terms, since they are squares, are always positive, and your middle term takes its sign from the sign that is in the center of the binomial. Let's do one more. X minus 1/4 squared. So square the first term. Multiply these two together. Now that's going to give you a negative 1/4. Now you're going to double it. So multiplying 1/4 by 2 becomes 2/4, which actually ends up then as a negative 1/2 x. And now we square our second term of the binomial to get our third term of the trinomial, which is a 1/16. Okay, so these are perfect square trinomials. Now what we're going to lead into in the next part of this is when we only have part of our perfect square trinomial and we need this term here. Now notice this is in the form of x squared plus bx plus c, which is the standard form for the quadratic expression. And we're looking at our b term here often. And how did we get the b term? Well, we multiplied these two terms and then doubled it. And we'll need often a new c term to make what we will have in the next part a perfect square trinomial. And this is all part of what is called completing the square. So what we have here then is the first two terms of our trinomial, which is x squared plus bx plus c. But we want this to become a perfect square trinomial. So we have the x squares, okay. We have our b term, but we don't have our c term. And we want to develop a technique for doing that. So I'm going to suggest you put a set of parentheses to indicate that you're going to square something that we used in the earlier part to get our perfect square trinomial. So we know to get this first term, we just needed to square this x. And the sign is what our middle sign is. Now, how did we get our b term? Well, we multiplied these two together and then doubled it. So if we doubled it to get the 8, what was it originally if it was doubled? And the answer is, well, you divide by 2, or take 1/2 of 8, and that will be 4. Now, to get our new c term here, or in this case, just to complete it, we're going to square 4 and get 16. We now have a perfect square trinomial. All right, let's follow that same technique. Now, they're not always going to be that easy. But again, you want to develop a protocol, a strategy for doing them. Well, our x squared, we know this is going to be an x. This positive sign goes right here. Now, again, we multiplied these two together, doubled it to get this. So how do we undo the doubling of something? Well, we take half of it, or multiply it by 1/2. So that becomes 3/2. So now how do we get our new c term? We get our new c term by squaring this, and this becomes a positive 9/4. This is now a perfect square trinomial, and if we factored it, would factor into this, and of course if we expanded this binomial, would become this. All right, let's try another. Again, the technique is you have your first part of the trinomial and the middle term, and you're looking for what is the c term in this process of completing the square. So we set it up like so. Our x comes down here. Now, what is half of 7? Well, 7/2. And now how do we get our c term? We get our c term by squaring this, and this now becomes a positive 49/4. This is a perfect square trinomial that if we were to factor it, it would become this. And this is the technique we're featuring here today. So we have developed some properties of completing the square. We now want to use this technique in solving quadratic equations. Now in this case, we have a quadratic equation in standard form, x squared plus bx plus c equals 0. But does this factor? And the answer is no. There's no factors of this that will ever work out, so we can't use factoring. So we're going to use the process called completing the square. And these are the steps. Normally you start with it in standard form, and then the first thing you do is take the c term that's here, which is the c term, and bring it to the other side. Just change its sign. Now what we want to do is find out what will our C term here become to make this a perfect square trinomial that will factor into a binomial that's squared. Well, we can use the technique we just went over. We're going to take that, and that becomes x. Our sign is negative. Just bring down our sign there. Now, how did we get our b term? Well, we multiplied these together, then doubled it, and then we got a negative 10. Well, if you doubled something to get a negative 10, how do you undo the doubling? You divide by 2, or take half of negative 10, which is a negative 5. We now have a binomial that, to get our c term, we would have to square a negative 5, and this gives us a positive 25. Now, up to here, as we said, it was an equation. To keep it an equation, we have to add 25 to this side as well. So this is still following our rules of an equation. So when we factor this, we get this, and this now equals 21. So a technique that we worked on for finding what x is when we have something squared is to take the square root of this side. That'll just give us our radicand. And we must take then the square root of the other side, which is plus or minus 21. The square root of 21. So now to solve for x, all we need to do is transpose the x to the other side, change its sign, and we get the solution of this quadratic equation as x equals 5 plus or minus the square root of 21. And the technique we used to solve it was completing the square. Now, there are more difficult examples, and maybe I'll do one of those too. They get to be a little more difficult when you have a b term here that ends up as a fraction. But that's okay. We'll work it out. 2x, x squared minus 5x. We're going to take our c term, move it to the other side as a negative 2. Put our parenthesis. We're using this technique. This is x minus half of that is 5/2. So to get a perfect square trinomial here, we have to square this term to get our new c term, which will be 25/4. Now this is no longer an equation because I've added 25/4. But if I add 25/4 there to both sides, we now have an equation. And in order to actually add these together, I need to change my negative 2 to a negative 8/4. Remember, a negative 2 over 1, just multiply both by 4/4 to give you a negative 8/4. Now I can do the actual addition here, and I will get 17/4. So now we still have an equation, everything balances, and the technique we used so far was completing the square. Transferring the positive 2 to the other side as a negative 2, completing the square to find what our new c term was, factoring that into this, and now taking the square root of both sides. So this just becomes our radicand, x minus 5/2 equals, now 4 is a perfect square, so I can write it as plus or minus the square root of 17 over 2. And now just taking this to the other side, I get x equals 5 plus or minus the square root of 17. And since we have common denominators, we can put it like so. Now, it gets a little more tricky when there is a value in front of the x squared here, where you have to divide by that, and that just gets very complicated. But there are other methods, as you will find, for dealing with this, and sometimes completing the square is a very, very easy way to go. And we've given you some examples, and hopefully this is helpful to you.